as I mentioned, I really like ANOVA because I think it's very powerful. But I wanted to go through. I have a slide that says example for calculations. I believe it's slide 54 in my slides. Um, and I took a picture of this and I will post it because there are a lot of calculations involved. But there are a few things I do want to emphasize. And please go through the audio in the lectures because I go through it in much more depth, and you can also see, um, like where when I'm talking about something, what the equation I'm talking about regarding to is. So it makes it a little easier. But I just want to emphasize, the whole point of this test is to get the F statistic, right? And to compare that to our critical F value to figure out whether or not we can reject or accept the null hypothesis. And our F value, and by the time you see this slide, I will talk about how the F value is, if it's closer to 1, then you fail to reject the null hypothesis, but as it gets further away from 1, then you will reject the null hypothesis. And the reason why is because you're looking at the mean squared between over the mean square within. And when this numerator is much larger, so when there's no effect from treatment, then these two, the numerator and the denominator, will be closer to 1 because they will be equal. But when you have a treatment effect, then this numerator will be much larger, and so that will cause your F value. So when this goes up, your F value will also go up, and so it will be further away from 1. So the larger effect by your treatment, then your F value will be larger. Okay, so I may have to erase things because my board is too small, but this is essentially, I just took down the most pertinent information from the slide. And so on that slide, it shows every single individual score. Let me read you the study, sorry. So what this study is this study was interested in examining people's preferences for their distance, the viewing distance from a 42-inch television. So there are 4 viewing distances. There is 9 feet, 12 feet, 15 feet, and 18 feet, with a separate group of individuals participants studied in each distance. Each individual watched a 30-minute television program from a specific distance and then completed a questionnaire to say their preference. So what we want to do is to determine whether or not there are any significant differences among the 4 viewing distances that were tested. So in the table, you can already see that there are already some things calculated. So the treatment totals are already calculated for each group, so that's T. And then the sum of squares is also calculated for each group. We also have, so G is the grand total. That's already calculated, as well as the total number of participants in the entire study. And then I will also, for this problem, I will also give you x squared, the sum of x squared, which will go into the sum of squares total equation. Okay, I'm never going to have you calculate x, because this is just basic addition or these values. I will always give you something similar to this, okay? So we're going to go through the 4 steps for hypothesis testing with ANOVA. So the first step that we have to go through is state the null and alternative hypothesis. So I don't have very much room, but I'll write it over here. So our null hypothesis is that the means for each group will be equal. Okay, so mean 1 for group 1 will equal mean 2 for group 2, mean 3, and mean 4, that they will all be equal. So this is the null hypothesis. The alternative hypothesis would be, for this problem, we'll say that at least one mean is different. Okay? Okay. So for this problem, we'll use an alpha equal to 0.05, and I give that to you in the slide. And then let's, so then we have to figure out the critical region. So first we need to figure out the degrees of freedom. Okay? So I wrote down the equations up here: degrees of freedom total, degrees of freedom between, and degrees of freedom within. I also want to get my calculator ready. Let's see. Okay, so I'm going to have to write right here, and then after I finish this, I'm going to erase it so that I can work on the sum of squares. I think that will be the best. I'll try to write really small. So let me just put a line here so it's not confusing. So degrees of freedom total would be n, the total number of participants in the study. So that's what that was given, right, in the problem. So it'd be 20 minus 1, which will equal 19. Then for this is k is the number of groups. So I before this slide, I list all the equations too. I think sometimes it's easier to see the equations written out all at once, but on the PowerPoint, I give all the equations. So I have a degrees of freedom slide, then a sum of squares slide, and then an f-test slide. So, and it will say this is k is group minus 1. So there are 4 groups in our study, so we do 4 minus 1, and that is 3. 4 groups, okay. And then we need to do sum of squares within. So in the table that was in the slide, it shows each of the groups have 5 scores within each group. So in that table, so that's all I'm looking at is just that table, right? And so what that means is we will do for each group, so for the within, degrees of freedom within, we would do 5 minus 1 for each group and add that up. So 5 minus 1 is 4. So I'm going to add up 4 times. So it'll be 4 plus 4 plus 4 plus 4, which is 16. Okay? And then we know that our alpha value is 0.05. So we're going to use, so what we're doing right now is, I stated, sorry, I'm going so fast. We stated the null and alternative hypothesis, and now we have to find the critical F value, right? To know where, at what point, what's the criteria for rejecting. And I will say, so I have this table printed out, the F score table. So what I have to look at is I go to, so the numerator is the number of groups, it's the between, right here. And the denominator degrees of freedom. So I'm just looking at the table. It has numerator degrees of freedom across here, and then denominator, you have to go down the table. And then we have our significance level at 0.05, okay? Which is the second column. So my numerator, my between is 3. And then our within is 16. So to go, I'm going to the second page. 3 and 16. So I see for 0.05, a significance level of 0.05, I see 3.24. So that's our critical F. Goes, yes, 3.24. Okay. Let me take a picture of this. So, or I can't take a picture because I'm taking a video. So I'm gonna erase some of this. Actually, I think I can keep working over here. So now that we found the critical F value, now step 3 is to calculate our to collect data and calculate the F score for the F statistic for this data. So what we're going to do first is calculate the sum of squares total, because what we're going to do, we need all these numbers to figure out the final all these steps go into figuring out the F statistic. Okay, so okay, sorry, I'm just making sure I did everything correctly so far. So I have all this data, these numbers within that were given. So I'm just using things that are given right now, okay? So we have the sum of x squared, which was given in the problem, that's 262, minus g squared. Is it g squared? Which is, we need to square the g, the grand total. So this will be 60 squared all over the number of participants n. So that's 20. Okay. So I get 182 for sum of squares total. Sorry, it should be, no, I made a mistake. It should be 82. So 60. Yeah, sorry. I don't know why I thought it was one. It's 82. Okay. So then you need for the within, so remember within is looking at within each group. So we need to sum the variation within each one of these groups. So that, and that's given in the problem again, okay? So the sum of squares is 8 plus, so I'm just looking right here. I wrote this down, it's in the slide. 8 plus 8 plus 10 plus 6. So that's 32. Oops. And then to get between, you do sum of squares total minus what's within. So the total is 82 minus 32, which is 50. Is that right? I'm so bad at mental math. Okay, that's right. So then we need to calculate the mean squares between. So we're gonna do, so here's the between, which is, and we divide that over, this was wrong. Wow, okay. Okay, so, right, because we're calculating the mean squares of between, so it's sum of squares between over degrees of freedom between. So for the between, we just calculate that. That would be 50 over degrees of freedom between, which we calculated earlier, which is 3, which equals 16.67. So obviously if I had more room, it wouldn't be as messy. I apologize for that. Let me just draw a line so it's a little more apparent what's going on. And then I need to calculate ms within, which equals the sum of squares within, which I calculated here, which is 32, over degrees of freedom within, which is 16. That's 2, right? Yes. I told you I was very bad at math. So then we calculate our ms between, again, so what this is looking at, what the f-score is looking at is how much variation is there in the between the groups, right? Because what we're interested in is that, is there a significant difference between the groups? So we're doing all of this because we're trying to figure out between the groups what is different, okay? Is there so much variation that it's statistically significantly different? Okay, so our ms between is 16.67 and the ms within is 2. So our f value is 8.3. I have 8.34. Wow, that's a big, that means there was a big effect from treatment. So if I look back at our critical value, I can say that so we finished step 3, right? So now I'm looking at step 4 of the hypothesis testing, and we find that the f value is much larger than what we calculated for the critical f value. So what we can say is we reject the null hypothesis because this f value is much larger than this f critical value. And so that's the decision.